Hey, welcome to the last Scribblecast in Module 3. Today we're talking about yields, specifically theoretical, or yields we can get using stoichiometry, and actual yields, ones that we would get from an experiment or a lab. First, let's look at the theoretical ones, and these are ones that we've been doing in lots of the last Scribblecast or last sections, and those are ones we get from stoichiometry. Every time we do a stoichiometry kind of question, what they're asking is, theoretically, what would you achieve? So for example, let's do this question here. And we'll do it with the stoich like we've always done with our river. And our answer that we get at the end will be a theoretical answer. Okay, 5 grams of KClO3 is heated, decomposes according to this equation. Calculate the theoretical yield of oxygen mass in grams. Okay, I've got an equation. Let's balance it. Oxygens are out, so maybe we should make them common denominator. So that's 6 oxygens there, 6 oxygens there. We're good. Oh, but I need 2 potassiums, 2 chlorines there. Balanced. So I have a balanced chemical equation. Now let's determine our given and our asked. We're given a mass of 5.00 grams of KClO3 and calculate theoretical yield of oxygen mass in grams. So what is the mass of oxygen that we get in the end? Okay, so I've determined given. This is my given side. This is my asked side. Now I can proceed to do my theoretical calculations, stoichiometry calculations, to determine what mass I think that I should get. Okay, so let's start. So I'm starting at a mass, that would be here, Solidsville, and I need to go down to moles, of course. Then I'll need to go across the river, and then they're asking mass, so I'm going back up to Solid-Dale. So it's a 3-stepper. So first step, I want to take the mass of KClO3 and I want to convert it to moles of KClO3. Okay, so I have my formula for figuring out moles is moles is equal to mass over molar mass. The mass is 5.00 grams. The molar mass I figured out is 122.55 grams per mole. Okay, so when you do that division, you come out to 0.040799, etc. moles. Again, I keep that number in my calculator. I only round off at the end. I've got 3 sig figs here, so in the end I'm going to round to 3 sig figs. Okay, so that's this step here. I've determined moles of KClO3. Now I have to get across the river. This side is the KClO3 side. This side is the O2 side. So I have to convert my moles of KClO3 to moles of oxygen. Let me just write that down. So moles of KClO3, and I'm converting that to moles of oxygen. Okay, so I write the number of moles I have down, 0.799, etc. moles of KClO3, and I times it by a mole ratio, which is in my equation there. So KClO3 goes on the bottom, 2 KClO3s, and oxygen, the 3 has to go up top, 3 O2s. So times this number by 3 divided by 2, and the moles of oxygen comes out to 0.0611995, etc. moles. Okay, so I've gotten now across the river. So last step is to take and go from moles of oxygen up to mass of oxygen. So I want to go moles of oxygen, and I want to convert that to mass of oxygen. Again, my formula for that is moles is equal to mass over molar mass, but then I need to revise it because I'm searching for mass. So the revised formula would be mass is equal to moles times by molar mass. The moles we just found, 0.6119995, etc., moles multiplied by the molar mass of O2. Oxygen is 16, there's 2 of them, so it has to be 32. So 32.00 grams per mole. So the mass of oxygen comes out, if my calculations are right, 1.9583 grams, etc. I have 3 sig figs, so it'll be 1.96 grams. Okay, so the question asked, what is the theoretical yield of oxygen mass in grams? Here's my theoretical yield. Theoretically, if there's no errors, nothing goes goofy in my experiment, I should get 1.96 grams. So it's a theoretical yield, or sometimes we call it a calculated yield. Now, if I actually do the experiment, and if I only get 1.78 grams instead of, what was my number? 1.96. So I only get 1.78 instead of 1.96. The question is, what is the percent yield? So to determine percent yield, we do it just, I guess, very similar to what you would do if you were figuring out your percent on an exam. The percent yield would be what you got. So in my experiment, I got 1.78 grams. And theoretically, or my total mark on or what it was out of, and this is sort of what I can think of my stoic number as being. So it was out of 1.96 grams. So if I divide those two, multiply by 100%, it'll tell me what my percent yield is. So 1.78 divided 1.96 times 100 equals, so 90.816, we'll call it 90.8%. So my percent yield for this experiment, if I did the experiment and that's the weight of oxygen that I got, the percent yield would be 90.8. Oftentimes when you do an experiment, they require a certain percent yield. And if you get lower than a percent yield, then you must have performed something improperly in your experiment, and you need to do it again. I know some of the labs in chemistry 95, and even some of the ones in 85, that's what we do when we determine what your percent yield is. If it's less than a certain amount, then we know that you must have performed some calculations or some procedures incorrectly because you didn't get enough yield. And I guess unless you can account for those with lots of sources of error, like you dumped some of it out by accident or something, and I don't know if that would be a good source of error, but unless you can account for it, then in many labs we would dock percent because your percent yield wasn't high enough. Okay, so in this little scribblecast we looked at two things. Theoretical yield, this is our calculated one. This is the one that we get from stoichiometry, doing our mathematical calculations. So theoretical, actual yield are things that you get from an actual lab. And using a combination of those two, I can determine what a percent yield is, and based on that say, yep, great job in the lab, or you might want to be more careful next time. Okay,